Just like to, thank everybody for joining. This is a live webinar to discuss an introduction to 5G and security. My name is Josh Arsenio. I'm a Director of Advisory Sales here at Security Compass. I'll be one of your hosts. I'm also joined by Paul.
Hi, my name is Paul Riviere, and I'm the Director of Research and Development with the Security Compass Advisory Team. And I basically just oversee our various R&D initiatives.
Great. So before we get started, just a couple of housekeeping things. We are recording this webinar, so we'll make it available today after today's event. You'll receive an email with a link to the recording. And eventually it'll work its way over to our resources page on our Security Compass website. So if you go to resources.securitycompass.com, you will find this, as well as a bunch of other webinars and other materials we've produced. Second, encourage everybody to raise questions. There's a Q&A chat here, and so we'll address questions at the end. Feel free to pop your questions in at any time, and then we'll all discuss that at the end of the presentation. If we run out of time, that's okay. We can stay late. If we get a lot of questions at the end, we can stay and make sure that they're all answered. And just to give you, some background, we hold these kind of virtual conference type talks, these webinars, about once a month, wide range of cybersecurity topics. If you've attended any of them in the past, thanks and welcome back. For those who may not be aware of us, who Security Compass is, we were founded back in 2004 as a boutique pen testing consultancy services. But today, we've really kind of grown our presence, and we have one of the largest consultant teams in Canada focused on pen testing, cloud security, and red team related services. But again, for today's webinar, we're taking a deep dive into an introduction to 5G kind of fundamentals, how it works, how it operates, the architecture of it, and then dive into some security details. For the presentation, I'm pleased to have Adam Greenhill, who's a senior consultant here at Security Compass, who specializes in research into emerging tech, IoT devices, device testing, and obviously 5G. So we're going to do a few polls that will pop up here and there through the presentation. You'll only see the poll questions if you're using the Zoom app and not the web browser plugins. So don't be alarmed if you don't see them if you're using the web browser, but if you do see them, it'll help to kind of enrich the content and give us an understanding of who's here, and then we can steer the content appropriately. But before I pass the mic over to Adam to kick off his presentation, we'll do one of those poll questions. Okay, so yeah, this is just kind of general interest, like, why are you here? Are you interested in just general interest? Are you implementing a 5G network right now, perhaps at a telecom, or you're incorporating 5G support in commercial products? You're more in the IoT space, automotive. Great. Still some people answering. I'll give you just a moment. Right, so sharing the results here. It looks like most folks have just a general curiosity, passion for technology and security, and want to find out what's going on with 5G. But there are, quite a few people here that are active in industry, including telecommunication providers and, other industries that would closely work with 5G. Great, it's awesome. So I'll pass the mic over to Adam to do a presentation, and then we'll do Q&A then. Adam?
All right, thank you, Josh. I am sharing my screen now. Can you guys see that?
Yep.
Awesome. Well, thank you everybody for coming, and welcome to Security in 5G, a brief introduction. So the agenda for today is I'll be giving an overview of what 5G is, talking about its advantages, the network security architecture, and then finally my concerns with it. So who am I? As Josh introduced, I am a senior consultant at Security Compass, been pen testing for about 4.5–5 years now, mainly doing web, mobile, network assessments, but occasionally get to do some fun stuff like IoT and telecom stuff as well. And here's my contact information below if you're looking to collaborate or reach out to me for more information. So I like to start this presentation with a quote. Back in May 2019, there was a 5G security summit in Czech Republic. And during the opening address, Andrej Babiš, the prime minister, said the following: by protecting the 5G network, we'll be protecting the very fabric of our societies, our ability to thrive, even to exist. And this really highlights the importance of securing our 5G networks. So with that in mind, what is 5G? 5G is the 5th generation standard of cellular technologies, but it doesn't really explain what 5G is. Is 5G just an increase in cellular data transmission speed? I mean, we're going from 4G to 5G. Do things just get faster? Well, this is part of the equation, but not everything. Maybe 5G is just a new radio frequency, a new band of radio frequencies. Again, you probably think you have millimeter wave, and this is part of 5G, but not the whole picture. Is 5G a complete re-architecture of how cellular communication works? See, this is a more accurate definition of what 5G is. You see, 1 to 4G were really optimized for people to communicate with each other, voice, text messages, etc. But 5G is a complete change. It has a flexible architecture that can optimize for really any kind of communication. So on top of that, what are some of the other technology advantages of 5G? Well, for starters, 5G supports an extremely high density of devices. In 4G LTE, it could really only support about 4K devices per square kilometer. Now in 5G, that is greatly enhanced to support about 1 million. And this can facilitate things like a smart city, where you have IoT devices in everything from sidewalks to street lamps, in your pocket, everywhere. Another main advantage to 5G is ultra low latency and high reliability communication. And this can really be exemplified with vehicle-to-vehicle communication, or this idea of 2 vehicles in transit communicating to each other. Because if 2 cars are traveling on the highway going like 100 kilometers an hour, you need the communication to be very quick, very reliable, or else those things can't really talk well. And the last main advantage to 5G is huge throughput. Now, we will definitely be benefiting from the other advantages as well, but this is something that we'll literally be able to hold in our hands. Because while 4G LTE does support streaming high definition content, it really can't do it to the capacity that it can in 5G. So that's where we get mass 4K video streaming. Now we'll talk about the network architecture of 5G. And I did see that we do have some people who are just attending this talk out of general curiosity. So they might not have a deep understanding of the technological terminology that I'll be talking about. So to help everybody follow along, I have this diagram to kind of illustrate what section of the 5G network I'll be talking about throughout the presentation. To start, we have user equipment. Now, this is a very simple concept to understand. It's what's in your pocket right now. It's any device that can connect to the 5G network. It could be a cell phone, autonomous vehicle, street light, anything. The second major area is radio communication. Now, this is the wireless technology that helps to facilitate the cellular communication. And in 5G, it operates across a very wide spectrum. To easily understand this, though, we can break it up into 3 major bands. We have the low band, which effectively allows for great coverage, because the low band can travel far, but it can't produce the high transmission speeds that we can in other bands. Skipping over the medium band for now, getting into the high band. High band is the complete opposite of the low band in the sense that it doesn't facilitate a large geographical coverage, but it can produce extremely fast transmission speeds. This is where you'd find the millimeter wave that I talked about earlier. And of course, the last band is the medium band. Excuse me. And this is where we kind of compromise on both areas, where we don't or we can achieve a large geographical coverage. We have a quite moderate coverage here, and also a moderate transmission speed. So compromising on both ends there. And there's two main technologies to help facilitate this radio communication. One is MIMO. MIMO stands for multiple in, multiple out. And it was a technology in 4G LTE, but it's been greatly expanded upon. And MIMO is all about the simultaneous sending and receiving of radio signals. Because in 5G, we're talking to a lot of different devices at once, so we need to be able to do that. And the second main technology here is beamforming. Now, when you think of a traditional radio antenna, which broadcasts in an omnidirection, it's pretty inefficient because we're potentially broadcasting to places where there's no devices located. So beamforming tries to make this more efficient by only broadcasting in concentrated signal streams to where we know devices are. And that's radio communication. The third area is the radio access network. Now, these are the cell towers and the supporting infrastructure that act as effectively a gateway into the core network. This is the area that your cell phone will connect to. And some of the functionalities that this radio access network will allow for is setting up connections, routing data, managing quality of service, these types of things. And last but not least, we have the core network. Now, to really understand the difference between 4G and 5G, let's look at a trend that's in just in general in the technological space, and that is companies moving to the cloud. See, companies push their applications and network infrastructure in the cloud for not only greater cost savings, but also higher resiliency and numerous other benefits. And this is what 4G to 5G has done. 5G has effectively virtualized the telecommunications stack and stuck it into the cloud. And some of the key technologies that this can enable is something like network slicing. And network slicing is where we have multiple end-to-end networks within the core network. And what this allows us to do is have a dedicated network for, say, voice communication or text messages. The possibilities here are effectively limitless. And by allowing dedicated streams for a certain type of data communication, the core network can really optimize for that, ensuring that the highest quality of service is always achieved. And the second major technology here in the core network that's really new to the telecommunications, cellular technology is the mobile edge computing, or the multi-access edge computing, also known as the MEC. And this is where the 5G computing is effectively pushed to a geographical location close to the user. And this greatly reduces the network latency, because instead of your data having to travel all the way across the country to get processed, it can be done within tens of kilometers. So way more efficient kind of across the board. All right, now we're going to be talking about security architecture. And I believe we have a question.
Yeah, before we go over to security architecture, we'll just do another quick poll question. So just, not necessarily your personal interest, but just where do you think the responsibility of security really lies? Is that more a device manufacturer? Is it really up to the standards to make kind of, secure by design? Making sure that the security ergonomics of deploying 5G is really lies in the standards. Is it completely up to the people that implement telcos, for example, or is it really the industry that's benefiting from it? Should they just assume that it's an untrusted network and just build security into how they're using it? Or all of the above. And surprise, surprise, it's all the above. That's really it. Defense in depth, security in depth. It's got to be at all stages. So I guess that was an easy one. All right, back to you, Adam.
All right, cool. Thank you, Josh. All right, so now we'll talk about the security architecture, or the security controls that have been implemented by design into 5G networks. And the first one here that we'll talk about is trust. Now, if I was a telecommunications company, there's two main areas that I'm concerned about, or two main trust boundaries coming from, or places where there's untrusted data coming into my network. And that's one, from the user equipment, because how can we trust that they are who they say they are, for instance? And two, coming from other telcos. As you can see, there is a pipe in between telco A and B here. And you see, unlike your traditional networks, a telco can't just firewall off all the internal traffic coming from another company, because telcos are always in constant communication with each other. So it creates a bit of an interesting scenario of trust. Now, in 3G and 4G, trust was really only, or trust controls were really only enforced in the outer perimeter. This is between the cellular device and the base station. In 3G and 4G, there was mutual authentication between these two components, where each one will authenticate to each other. But as you'll see in the middle here, in between two different telco companies, there is no trust control. Any data from one to another is just blindly accepted. So in 5G, things change pretty significantly. So not only do we have the mutual authentication between the user device and the cell tower, but we also have a lot greater trust controls in between telcos as well. And that's achieved through the Security Edge Protection Proxy, or the SEP. And this acts as a gatekeeper to not only authenticate data coming into a telecommunications network, but also ensuring that it's encrypted and validated as well. But what happens if somebody breaks into a telco building and has access to the underlying data? What happens if the call is coming from inside the house? And that's where data transmission security comes in. So to kind of walk you through the different generations of data transmission security, let's start with 1G. And there was no encryption or integrity controls here at all. In 2G, that's where we start to see some between the user device and the base station. 3G extends this one hop further into the radio access network. And then 4G is where we start to see a complete end-to-end encryption possibility. And this is great, but the problem with 4G is the fact that there's one set of cryptographic keys used for the internal communication. So if that's ever compromised, all the data is compromised. Now, 5G continues to have this trend of end-to-end encryption. However, it's taken a lot of the components from 4G and broken them up into subcomponents. Now, instead of having one cryptographic key encrypting all of that data, that cryptographic key has similarly been broken up into subkeys as well. And each of those individual keys will encrypt hops from, say, component A to B, and then a second set of keys from D to C. And so if one key is compromised, the rest of the data in the network is still secure. So it's a lot more resilient to compromise in that way. The next area of security architecture comes about user privacy. In the previous generation of cellular technology, 4G, there was this International Mobile Subscriber Identity Value, or the IMSI. And there was a lot of issues with this identifier, because it's transmitted constantly in plain text from your device, because this is the value that's used for you to connect to a cellular network, and it starts the conversation that is later produces the conversation where cryptographic keys and protocols are negotiated. So it has to, at least in 4G LTE, be broadcast in plain text. And the problem here is it allows users to be tracked, because you can just follow that identifier around a given location and you know where a user has been. But it could also potentially be replayed as well, allowing fraudulent activity to occur. So in 5G, the IMSI has been removed outright. But replacing it is something called the Subscription Permanent Identifier, or the SUPI. Now, the SUPI resides permanently in your SIM card. It never leaves. But what does leave is an encrypted version of that. See, the SUPI is it's encrypted with the home carrier's public key. And that encrypted bundle, which is called a subscription concealed identifier, is sent off instead. So now we're no longer just transmitting plain text identifiers. Much more secure. And here's just an image of that. And the last main area of security architecture comes with the virtualization and software-defined networking, which, like I said before, happens all within the network core. And see, the virtualization enables 5G networks to be effectively constructed like Lego pieces, where you can build it out on the fly how you want it to be. So say there's a championship game in a major city. Well, now we can build it out to support that. You know, we have the ability to do that. But this virtualization also allows us to treat each of those individual subcomponents uniquely, in the sense where maybe one area needs to be restarted or redeployed. We can really easily do that without affecting the rest of the network. So great resiliency here. The second area of security that is enabled through virtualization is on-the-fly security as well. And this is where, say, there's a new attack that's discovered for the internal core network. Well, we can deploy firewalls or network controls or even segmentation, you know, at the flip of a switch in order to protect the network. You know, at least until there's a dedicated patch or something to fully remediate the issue. But you know, we can apply these mitigations very easily. And the second area of security that can be implemented through virtualization is through network slicing. So I talked about earlier about how we could treat, you know, data uniquely that's running through the core network. And this also allows us to ensure that if we know there's sensitive information thrown through the network, like payment card information or health information, well, we can ensure that that data has all of these security bells and whistles on it to protect it. So we just have greater control across the board when it comes to the security of the components and the data running through the network. And now we're coming to the last section here, which is related to the privacy and security concerns of 5G. And there's two main sections that I have here. The first one is related to inherited flaws. I didn't really get into this previously, but effectively, long story short, it will cost countries billions of dollars and multiple years to upgrade their existing 4G LTE into 5G. So to help countries and companies do that, the designers of 5G have outlined a number of hybrid deployment models that, you know, a country can effectively use as guidelines to slowly transition over a long period of time into 5G. Now, the issue with these hybrid models is because they're built off of the previous generations of cellular technology, they also inherit all the flaws of those generations as well. And what do I mean by that? To start, we have signaling protocols. Now, signaling protocols are effectively the protocols that were used in the legacy cellular technologies to perform things like, you know, routing telephone calls or routing text messages, things like that. And when they were designed, they didn't really have security controls implemented. You know, take SS7, for instance, which was produced in 2G and 3G. And it didn't have any authentication or integrity controls at all. So if somebody broke into your telco and had access to the network, they could very easily man in the middle and intercept any SS7 data that flows through it. Now, in 4G, that's where we started to see things change because diameter was introduced. Diameter brought with it the authentication, integrity controls, and encryption that SS7 lacked. However, there were still flaws with this protocol, like the fact that, you know, in areas, user information could be leaked, compromising the privacy of users on the network. And that's even if encryption and the integrity controls are enabled to begin with, because these were optional. You didn't have to have encryption or integrity controls on your diameter protocol at all. But the last legacy protocol that I find particularly interesting is GTP. Now, GTP is all about, you know, unlike the previous two legacy protocols, GTP will still be used in a fully deployed 5G network. And GTP has a number of issues with it, like, an attacker can abuse it to perform fraudulent activity, and they could use it to achieve denial of service as well. So while the 5G specification isn't finished yet, maybe they will address this concern in a future release. That is my main area of concern, at least in terms of the legacy protocols. The next area of concern is related to downgrade attacks. So oftentimes when there is a new technology released or a new protocol, there's usually a grace period where an older, more out-of-date standard is still being supported. And it's allowing this older generation of standard that enables an attack, like a downgrade attack. And this is extremely common with cryptographic protocols that your browser uses all the time. However, when it comes to your browser, you have the major manufacturers of browsers like Mozilla and Google. They will slowly, by default, disable the insecure protocols like over time. And you, specifically the user, can go into the settings of your Chrome or your Firefox in order to disable any insecure protocols that you specifically don't want. It might impact how you browse the internet, but you have the choice to do that. When it comes to, before I continue, but after you disable these protocols, downgrade attacks are prevented because you can't use the insecure protocols anymore. And when it comes to cellular devices, you don't have that ability. There's no setting in your phone where you can disable connecting to a 2G or a 3G network. You just don't have that control. Now, EFF is currently lobbying the major phone manufacturers like Google and Apple in order to try to allow us to have this ability, but currently we don't have it today. You might be asking why EFF isn't lobbying to completely remove the ability to use these standards from newer devices. Well, if you're traveling across country or you're in the subway, you might see that your phone connects to 2G or 3G networks just because that's the only thing that's available. But I want to emphasize here, though, that even if you go out today and buy a brand new 5G phone, your phone will still be susceptible to downgrade attacks. So that's really where the main concern is this will likely be a problem potentially forever, but through EFF's help, we can hopefully address this soon. And the second section here, second setting or second group of issues that I have is related to out of specification issues. Now, the 5G specification is extremely detailed and it covers a lot of areas, but there's a number of different places within the 5G deployment that the designers have just deemed out of scope. And this is because, this is really in the hands of the, it's in the telcos implementing 5G, but also in the app developers who are developing applications that leverage 5G. And this is where I think the major concern is, because when it comes to like app developers, for instance, they have extremely strict, budgetary concerns and even timelines. And because of that, security might not be the top concern. So, that's where issues arise. And as an example of that, let's think about cloud computing vulnerabilities. So I'm not going to pick on any one company here, but there's a lot of examples of, even large organizations misconfiguring their cloud deployments and having, globally exposed S3 buckets from Amazon or any other kind of publicly accessible storage accounts. The examples are very numerous. And when companies are moving into the cloud and configuring these environments, it will be very easy for them to make similar mistakes. So yeah, I think telcos will definitely need to be worried about that external attack coming into their network from the general internet. But not only do they have to be concerned about the external attacks coming into their network from outside, they have to be worried about the internal threat as well. Because unlike the previous generations of cellular technologies, in 5G, you can just have arbitrary third-party code running in your environment. Now, I'm not talking about the core network, the internal area of the core network at all. I'm more concerned about the mobile or the multi-access edge computing areas, or those satellite areas that are geographically close to the users, because in these environments, companies can run their own applications. As an example, you might have Tesla running an application that can communicate to their cars, or Toyota, or any kind of example there. And if these environments are not properly segmented from the rest of the core network, you could potentially have situations where a rogue application can, try to talk to the internal network or perform mischievous things with the internal network. And that's a big issue. But another consideration is the application to application attack surface, where if the applications within the multi-access edge computing are not properly segmented from each other, they could potentially talk to each other or try to compromise each other's data. The possibilities are there. And I was going to create a proof of concept here in AWS Wavelength, because this is their 5G edge location product. And you can go right now and request access to it. But they never got back to me, so I never got to be able to actually create a demo for you guys. But if you are interested, you can also submit a request to get involved in the deployment as well. But the last major concern that I have in terms of cloud computing vulnerabilities is really related to the privacy concern. Because unlike the previous generations of cellular technologies, the telcos no longer own the data centers that houses all their data. Now you have situations where an entire country's telecommunications data is flowing through third-party data centers being, Microsoft, Amazon, Google. And, that brings up a ton of concerns that just weren't there previously, because, if you control your data center, you don't really have to care about, what happens to that data. So I think that'll be interesting as well, to see how telcos adapt to those concerns. And the second area of issues is related to the adoption of HTTP within the 5G environment. And see, in the internal communication, instead of having dedicated signaling protocols everywhere, some components talk to each other through HTTP. And this greatly lowers the bar for potential attackers to attack a given 5G network. Because instead of having to, learn what SS7 is in diameter and potentially having to create custom tooling, HTTP is very well studied, and you can very easily deploy your own HTTP, web servers within your own network and play around with that. So it greatly reduces the bar. And on top of that, we also have very well-known protocols like OAuth 2 and JSON leveraged in an environment. And the issue with these is that there's a lot of very well-documented attacks against them, very easy to follow guides that show you how to exploit these things. However, even though this is a concern of mine still, I'm going to give the advantage to Defender on this one, because while there are a lot of great resources on attacking these protocols, there's also a lot of great resources for developers to defend against it as well. So I think I'm going to side with the defenders on this one, but we'll see how things actually progress. And the last major concern that I have here is related to complications managing user privacy. See, in a couple of instances, we have this ambiguity of responsibility. The first one, 5G networks can very easily extend beyond a country's borders, and it can create a situation where you have an attacker in one country, a victim in a second, and a service provider in a third. And it's very easy in that situation for laws to conflict with each other. So what would take precedence in that scenario? But another example is the fact that multiple different parties are holding on to user data. You have the telco, the third-party app provider, and you have the underlying cloud provider. So whose responsibility at the end of the day will it be to protect the user? and their data. Because if that's not properly defined, you get these situations where nobody is really stepping up to the plate to defend and protect the user data. So I think in general, lawmakers and privacy advocates really have to step up to the plate and come to the table and establish clear-cut laws and guidelines for where, whose responsibility is for what. So we'll see how that plays out. And getting to the end of the presentation here. So in conclusion, 5G will completely revolutionize how everyone and everything communicates. And as you saw, when we were going through the security architecture of 5G and the previous generations, you can see that 5G is just much more secure than the previous generations. So that is great news. However, there's still some concerns that haven't really been addressed. So I think, we'll really just have to kind of play it by ear and take time and see how things progress, because only time will tell how these concerns will play out. Thank you, everybody, for attending. Are there any questions?
Thanks, Adam. Yeah, we do have some questions that came in. So I'm going to go through those. But yeah, first off, thanks so much for the presentation. It's great fundamentals and foundational knowledge. Getting some key concepts as to where the security concerns are, not just for people that are implementing 5G networks, but certainly for those that are planning to leverage it to kind of, come up with innovative and novel solutions that would depend on the types of possibilities that 5G would facilitate. Incredibly high density, the throughput is just incredible, and everything else went over. So that's awesome. Thanks so much. So before we kind of continue through the questions, I just want to kind of put out there, this is, the idea of this webinar was to really kind of build a baseline understanding of 5G's concepts. We are kind of continuing down this path of research, and we will have more on this topic for sure, and kind of diving deep into specific areas. We are open to collaboration. If you are interested in doing some 5G research with us, or if you have an interesting project you want to talk about, definitely reach out to me, joshua@securitycompass.com, or you can connect with myself or Adam or Paul on LinkedIn and all the other kind of social media. So just reviewing some of the questions here, it looks like we have 4. Okay, so about four questions. The first one here, you talk about scalability via cloud, but there's also a hard cap on 4,000 devices per square kilometers in 4G and 1 million devices per square kilometer in 5G. Is this a limitation of the RAN, the radio access network, I guess, RAN? If so, cloud scalability only seems like it would help so much.
Yeah, for sure. So there's kind of two ways to tackle this issue. So one, yeah, we are at the point where, the big issue is spectrum sharing and, the radio access network component here. So there will need to be an increase in, technology here. There will need to be some improvements there to really facilitate a greater need for different devices. But, 1 million devices per square kilometer is very large. So I don't know if we're going to reach that capacity anytime soon. So that's where I'm at.
Great. Another question here is, I think is kind of pulling on some of the trust boundaries and encryption that you talked about earlier. How does 5G facilitate lawful intercept, like Calypso? Yeah,
for sure. So I didn't really get into the real technical details of the 5G core network, but effectively there are within some of those subcomponents, there's basically direct access for law enforcement to come in and access not only the signaling data that's going through and managing the network, but also the user data specifically as well. So yeah, don't worry, the law enforcement will have full access to all data within these networks, for sure.
Worry or don't worry, depending on
yeah, I guess.
It's not true kind of end-to-end secure or end-to-end encryption in that way. So if we were creating applications and kind of applying, creating a solution that relies on 5G that really needed that privacy, looking at additional transport security for end-to-end communication is definitely still needed. Okay, so another question here is, and there's a couple that I kind of combined them because there's two different questions that were really quite similar. You mentioned that the SUCI, which I think is actually pronounced sushi or something like that, the SUCI helps protect privacy by preventing tracking. How does this work? If the sushi is encrypted with a public key, wouldn't it always be the same encrypted value sent? So if it doesn't change, can you still be tracked by sniffing?
So that's a really good question. So the subscription concealed identifier itself, as it's sent, is actually not a static value. So it is combined with a nonce, as well as a home network's ID if the servicing network isn't the user equipment's home network. So for example, if you're roaming. And there's actually been some research published on specifically the 5G, aka key exchange authentication protocol. And basically these researchers confirmed that both passive and active attackers, without any additional info, are not able to obtain that concealed identifier. So as an example, active IMSI catchers won't work anymore. Now the caveat there is, of course, that they, if in the lawful intercept case for law enforcement, they may have the telco keys that are provided to them. So of course, that would still work for lawful intercept purposes. But some random person with a software-defined radio like myself would not be able to get that information. They do have a theory, however, and I'm not going to get too deep in the weeds. They have developed a theory that it could be theoretically possible to track user equipment, but the practical implementation is questionable. So basically the way it works is if you eavesdrop on a 5G, aka key exchange between a servicing network and user equipment, you can later replay the service network traffic to every piece of user equipment that you see, and it'll reply with one of two responses, right? Either a MAC error, which would indicate that it's not the same device that you saw earlier, or with a synchronization error, which would mean that it is the same device. So there's some limitations here. Of course, practicality, you have to set up a whole bunch of these in an area that's, the area you want to monitor. You would have to find a way to de-anonymize the specific device if you're trying to target a specific individual. And also the research that was performed was not with an actual wireless live implementation by a carrier. So essentially they use software, a software implementation of the 5G aka protocol that was modeled after the specifications. So again, actual implementations may vary here.
Thanks, Paul. You referenced some research. Is that an available white paper that's kind of open?
It is. Let me look up the title. It's on, I believe it was arxiv.org.
We'll send a follow-up email. It's going to have a link to the conference recording, but we'll make sure we'll include a link to that white paper as well. Sounds like there's a bit more to that. So we have two more questions. If there's any more, keep them coming. Next question is, can you describe a little how CV2X fits into the overall security picture you've painted of 5G infrastructure? Not sure who wants to take that one up.
Yeah, I can talk a little bit about that. So the vehicle to everything communication, essentially that sort of depends on what the implementers want to use it for. A popular example that gets cited or talked about would be in the case of, let's say you're a car company and you develop an autonomous vehicle, and you have obviously a whole bunch of sensors collecting all kinds of telemetry data in your vehicle, and then you can have other vehicles obviously traveling down the road with you, and all that data can be sent to one of these mobile edge computing nodes that Adam was talking about earlier. So it's very close, so it cuts down on the latency, so you get high speed transmission, and it can perform the necessary calculations and then submit data back. So if there's an accident, or if you need to slow down, or any sort of emergency situation, it reduces the amount of time it takes to gather that data, make those calculations, and then return the results back to the vehicle itself, so that it can make decisions much faster than if you had to send that data, say cross country, or long distances to be processed.
Thanks, Paul. Another question here. This kind of plays on what Adam was saying about some of the flaws in implementations. But because the 5G ecosystem is modularized and pieces controlled by different parties, complexity goes way up. Not just how they're configured, but how people have implemented the standards, how they've interpreted. How will all the players make sure that the overall security is maintained? It seems to me that the complexity means a whole new set of vulnerabilities that will be difficult to spot, to troubleshoot, and to fix.
Yeah, for sure. So, the conversation has changed from 4G to 5G, because, in 4G, we just had boxes directly plugged into each other. So you're right, there were, attack surfaces that we didn't really need to consider in the previous generations. But in 5G, we have a lot more tooling that allows us to, to not only monitor these networks, but also protect them as well. So the complexity does go up, and companies will still need to, ensure that they have like penetration testing of these networks and, other, traditional network security tooling. But yeah, I don't think it's impossible by any means to ensure that these internal networks are secure.
Yeah, I think it's, it's pretty obvious that things have changed drastically. There's going to be new types of vulnerabilities that are going to be coming out. There's going to be a tremendous amount of security research in the coming year, 5 years, 10 years. Like we're seeing with the downgrade attacks, 2G and 3G. Like, these networks are still there. They're going to be around for a while. So even as we we move past 5G, these networks are going to be there for an incredibly long time. So yeah, any kind of project that is going to go into 5G, it really must include a security eye through it, just like any other development system project. But the stakes are just too high for 5G. And we're talking about companies, both in telecommunications, but also in industry, making huge investments and relying on 5G. So it's got to be done right, as much as can be expected the first time around. And then just having some really core fundamental understanding of how the technology works from all components in order to properly identify where vulnerabilities might exist and take steps to ensure that they have continuous visibility and ability to respond, right? Prevention, detection, respond definitely plays a role here. So that's the last question we have right now. Like I said, we're continuing to do research, and we'll continue to have webinars. And if you haven't visited resources.securitycompass.com, there's a tremendous amount of information there. Kind of related to this topic is there's a 5G blog post there that also written by Adam that goes into some, it's a good kind of bookmark page. Definitely have a read of that. And if anybody here wants to continue the conversation offline, definitely reach out. And if you have any ideas for future talks that you'd be interested in, any kind of collaboration on projects or research, reach out to myself or Paul or Adam, and we'd love to talk to you about that. Yeah, so with that, we'll wrap things up. Thanks again for giving us an hour of your time. Really appreciate it. We'll talk to you all again soon. Thank you very much.